Welcome back, Earth Science students, to our next video on ideal gas law. We're continuing with our work with our climate unit. We're moving away from ocean currents, and now we're going to start talking about air currents and air pressure and volume and how that affects our weather and how that ultimately affects our climate. I have this visual here just as a little representation of what we're going to be talking about. Okay, so we have all these air molecules in this container of a certain volume. If I push down that lid, okay, notice that I'm compacting all of those molecules, and so the pressure is going to go up. So when I decrease the volume, the pressure is going to increase. We're going to have an equation that we talk about here in a second. Other than that, this is going to be a really short video, but I have another video on air currents that I need you to watch this week as well. There's a couple of assignments, a couple things I need you to read, so make sure that if you can't find anything that you let me know. But without further ado, let's get right into it. All right, so let's talk about the variables in the ideal gas law. So we have PV equals nRT, so pressure, volume, equals the number of moles times the gas constant times the temperature. Okay, so our variables here are pressure, volume, number of moles, and temperature, and then our gas constant is the one thing that's held constant. So just a reminder, what is a variable? Okay, and so what it is something that can change in any situation. Okay, so in a particular situation, I might have pressure going up and down, volume might be going up and down, anything that can change in our situation. And then we have the opposite. What is a constant? Well, that's something that stays the same over an experiment or over time or forever, that sort of thing. It kind of depends on the situation itself. Okay, the gas constant R is always the same fixed number, and we use 0.082 liters times atmospheres over moles Kelvin. Okay, so just to get into these variables just a little bit more, P stands for pressure. Pressure is defined as the force or weight per area. If you've ever worked with anything with air pressure, you hear a lot that in the US we use PSI or pounds per square inch. Okay, so that's again a force or weight, pounds per square inch, which is an area. Okay, for our purposes, because we're talking about air currents and atmosphere, we use atmospheres. It's another way to measure pressure. Okay, volume, the 3D space that something occupies. So we're talking about air here. So the 3D space that air is occupying. For this, we use distances cubed. So for that, usually we use like inches cubed or feet cubed. Most of the time for our volume, we end up using the metric system, which is liters or milliliters. Mostly that's just because they're easier to use than things that are cubed. Temperature, the measure of the heat content of the air molecules or the amount of kinetic energy the molecules have. For us, we use Celsius, Fahrenheit, or Kelvin. Typically in this equation, we either use Celsius or Kelvin, one or the other. Fahrenheit, we don't use a whole lot in our calculations with this one. Okay, moles is the amount of atoms. Okay, so this tells you specifically that I have X amount of oxygen atoms in this given container. Okay, now one thing that you're going to need to be able to know is when I change one, what happens to the other ones. So let's do an example. On the left side of the equation, we have pressure times volume. On the right side, all you have to really worry about is number of moles and temperature, because if you remember, the gas constant is always the same. So if we have PV equals nRT, okay, if I say that I'm holding pressure constant, so I'm keeping the same pressure no matter what, okay, and I increase the volume, well, what's going to have to happen is that either the number of moles or the temperature is gonna have to go up to compensate for that. Okay, because if I increase the number on the left, I'm gonna have to increase the number on the right so that they still remain equal. Okay, now if I hold number of moles and temperature the same, okay, so the whole right side of the equation stays the same. Let's say it stays the same and it's 5 or something, and pressure times volume has to equal 5, and I increase the volume, well then I'm going to have to decrease the pressure to make sure that they still multiply to 5 or whatever I get on the right side. Okay, one example is like, let's say that N times R times T happens to be 6. Okay, and we start out with pressure times volume is 2 times 3. Okay, well, if I increase the volume from 3 to 6, well, the pressure is going to have to go down to 1 because it still has to be equal to 6. So it has to go 1 times 6 is equal to 6 on the other side. Hey, if you're a little iffy with that, just let me know, and I can explain it to you one-on-one, or try to write you something that makes more sense. Okay, so when I say hold something constant, that means to not let that variable change. So like when I said, if we hold the volume constant, it's going to be the same volume. That's a number that's not going to change. We're changing it into a constant rather than a variable at that situation. Okay, so what does this have to do with climate? Okay, it has to do with the atmosphere. Okay, so the amount of atoms and temperature change in the atmosphere as you go towards space. Okay, and this determines what your pressure is. Okay, so if you remember, atoms and temperature are on the right side of that equation, pressure and volume are on the left side. Okay, well, the volume of our atmosphere isn't really going to change all that much. Okay, but what does change are the number of atoms and the temperature. Okay, so if you've ever heard that like the air is thin at higher altitudes, that's just because there's less oxygen atoms. Okay, so there's less moles to have in higher elevations. Okay, and so then that affects the temperature, which affects the pressure, and so on and so forth. And overall, pressure and temperature are what guide our weather and our climate. Okay, if you've ever heard of like we're in a low pressure system or a high pressure system, okay, that dictates what happens to our weather. Okay, so the atmosphere has many layers. Actually, it has 5 layers, um, with a few little sub layers in between. You guys are going to do a reading on these 5 layers so that you guys can answer the check for understanding questions afterwards. Okay, so make sure you do this video, do the reading, and then you'll do the check for understanding. So the 5 layers are the troposphere, which is the one that's closest to Earth. Number 2 is the stratosphere, which is just above that. 3 is the mesosphere, then the thermosphere with the ionosphere contained in that, and then the last one is the exosphere. The way that I typically remember these things is that the exosphere is like exiting the atmosphere and going into space. Thermosphere. So thermosphere, you guys are going to read about it. It actually is kind of weird, where we get colder, but then in certain places in the thermosphere, we actually get warmer instead of colder, even though we're farther away from Earth. But you guys will read up on that, and make sure that you do that. Okay, the troposphere, stratosphere, and mesosphere, they all have their own special properties too, so make sure that you write those down as well. And other than that, that is all I have for you for the ideal gas law. Make sure that you do your check for understanding. Watch my next video on air currents, and then we'll do that one. And we are almost to the end of this unit, meaning that we probably will have a unit test in 1 week. Okay, so be prepared for that. Thanks for watching.